Chapter 3, Welding Process. The chapter contains general requirements for the welding process that may be used with the application covered in paragraph 1, 2. The process of the welding process covered the design manual are as follows. Shield metal arc welding, SMAW, the gas metal arc welding, GMAW. Free flight, transfer, pulse current without a position welding, short circuiting, flux core arc welding, FCAW, gas tungsten welding, GTAW, submerged arc, SAW, and exothermic thermit, and arc stud. Basically, electric welding processes that are produced with the electrode with the work of the price of the piece of the base metal, but the arc is formed with the passing of the current from the electrode to the working piece through the gap. The current melts with the base metal with the electrode of the consumable type, creating a molten pool. All solidifying the weld is formed, and an alternate method is employed for the consumable electrode, such as the tungsten rod. In this case, the welding is formed with the melting and solidifying of the base metal at the joint. Within some instances, additional metal is required, with this also added to the molten pool for the filler of the rod. Electrodes will, which become deposited welded metal arc available with various diameters and lengths, and welding molten pool must be protected with the ambient temperature to prevent contamination. There are 3 ways to do this to involve the flux in one, the flux in part of the electrode, or either as the coating of the wire or as the coat of a hollow wire. A second method is used with the granulated flux that is applied with separately before welding, and the third method involves the gas and helium, argon, carbon dioxide, in addition with shielding, and the flux may function as a deoxidizer to purify the deposited metal with the form of the slagging, protect the welding. Oxidation fluxation may contain the ionizing elements, providing with a smoother operation, allowing the elements to provide higher strength than iron powder with the increase the production rates. The selection of the electrode for a specific job can be based on the following 8 factors. Alright, here is your schematic drawing of the shielded metal arc welding. You have an electric holder, your electric arc, your grounded clamp to the workpiece, the arc electrode cable, the power source, ground cable to the electric holder. That's your shielded metal arc welding. Stinger electrode, arc, workpiece, ground clamp, ground cable, power electric MIG, or welding box, electric cable. Alright, the selection of the electrode specific job can be based on the following 8 factors: base metal strength, properties, base metal composition, welding position, welding current, joint design, fit up with the thickness and shape of the metal, base metal, the surface conditions or specifications. 8, in production efficiency of the job condition. The American Welding Society publishes a group of specification for filler metals and electrodes, recommendation for the welding process for which they are to be used. In addition, with the American Welding Society D1.1 describe the welding procedure to be used for the various welding processes. Or welding material, electrodes, welding wire, fluxes must provide with the satisfactory weld with being used the qualified welder, welding operating, use of the qualified welding procedure. Welding materials must comply with the applicable requirements of the American Welding Society D.11, American Society of Mechanical Engineer, Boiler Pressure Vessel Code, Section 2, other requirements in the contract specification. 3.3, shielded metal arc welding, SMAW. The most widely used method of the general welding application may be referred to as metal arc or manual metal arc or the stick electrode welding. Advantage of the shielded metal arc welding process can be used with welding must structurally allow steel with structurally alloy steels include low carbon metal steels, low alloy heating treatable steels, high alloy steels such as stainless steel shielded metal arc welding is used joining common the nickel alloys can be used with the copper aluminum alloys. The welding process can also be used with all position flat vertical horizontal overhead and requires only the simplest equipment. Thus the shielded metal arc welding lends itself very to weld into the field work figure 3.1. Disadvantage of shielded metal arc welding is clearly inferior to the gas metal arc welding, and it can only compares with the cost of the time and the materials needed to deposit the welded metal. The shield metal arc welding weld more slowly than does the gas metal arc welding. In addition, slack removal of unusual electrode stubs and splatters add on to a lot of the cost of shield metal arc welding. Later, 2 of the items account for about 44% of the consumed electrodes, and other potential costs is the entrapment of the slag and other forms of inclusion which may have to be removed. See processes and principles. The shielded metal arc welding process procedure are between the base metal and the electrode. The electrode put into the handheld clamp is we're going to go over these pictures as soon as I read the rest of that paragraph. Struck against the base metal within drum with the create a gap. All right, so let's go back. Alright, this shows your schematic diagram of shield metal arc welding. You have your arc stream, your solidified slag, the solidified weld on the base metal, the gaseous shielding envelope of the molten pool, your electrode coating, and the core wire of the electrode. This shows the weldability characteristic construction steels A36, A514, A56, U.S. Army Construction Engineering Research Laboratory, 1981. You have your travel speed in inches and minutes versus the current amperes, 60 to 110, 140 amps over 0 to 22 inches in minimum. This is your reprinted circular of TRM302 with welding characteristics with construction steel A36, A414, A56, Army Construction Engineering Research Laboratory, 1981. Current amperes 60 to 140 over the travel speed inches in minimum. So you got your lines around 75 and 100 and 130. Alright, this is your reprinted circular TRM302 welding characters of the construction steel A36, A14, A5516. Here's Army Construction Engineering Research Laboratory, non-copyrighted. Current amperes from 120 to 200. Your travel in speed inches and minimum. Your amperes line up around 130 and 150 amperes. In between your pre-reprinted circular TRM302 welding characters, construction steel, A36, A15, A1516, U.S. Army Construction Engineering Research Laboratory, 1981, copyrighted. At 115 amperes, you line up between 6 to 18 inches minimum, and from 145 amperes, you line up on the travel speed of 8 inches to 20 inches a minute, and 165 amperes you line up from 7 inches a minimum to 24 inches maximum. Other welding ability characteristics: construction steel A36, A15, A56, A16, U.S. Army Construction Engineering Research. Current amperes 130 through 210 over 0 to 228 inches in travel speed. And also your reprinted with the circular TRM302 welding characters of construction steel A36, A15, A16, U.S. Army Construction Engineering Research Laboratory, 1981. You have 140 amperes and 230. You line up around 150, 107, 85, and 220 around the travel in speeds and minimum between 8 and 21. Or your reprinted circular TRM302 welding steel characteristics construction steels A36, A15, A5516, U.S. Army Construction Engineering Research Laboratory, 1981. Amperes from 100 to 180. They line up at 115 from 6 to 15, and 140 from 7 to 114 travel speed in inches, and 165 to 8 to 16 inches minimum. Alright, the molten portion of the electrode fuses in the molten pool of the metal plate, producing the weld with the figure 3 tube of the shield metal arc welding, meaning the process of operating primarily responsible for the quality of the weld. Most electrode metals in transfer of the workpiece are possessed with thrown, but the free of the weld and spattered and vaporized. Often, the vaporized, some of the examples escape the surrounding air, becomes oxidized, appears as smoke or fumes. Electrodes using the shield metal arc welding has the special covering which serves as several purposes. Part of the covering contains the gas-producing compounds that, when heated, produce the gaseous envelope around the arc to displace air and stabilize the arc. The covering of the air also protects the molten welded metal from contamination by the air. Without stabilization, the arc would be erratic and would often short out, and generally would be hard to control. Different gaseous producing compounds are used with the coating depending on any type of the current, with the alternating current and the direct current. The covering also contains a slag form material, the mixture of the molten weld material, picking up the impurities of the welded material. The cleaning actions improve the quality of the weld. Most of the electrode contained does not become vaporized, but instead of the melted with the arc heat and forms the molten slag of the cover over the top of the welded bead. The molten slag cover the heat helps the cover and control the shape of the welding bead that helps hold molten welded metal in place during the out of position welding. Welding is overhead, vertical, horizontal position. Chapter 4 and 5 discuss the normal of the system, the color coded with the flux compensation other than data concerning the welded electrodes and shielding. Metal Arc Welding 5 distinct forces responsible for the transferring of the molten filler metal in the molten slag with the base metal. The gravity is the principal force for the accounts of the transfer of the filler metal in the flat position welding and another position. The surface of tension shows able to retain the molten metal and slag in the crater. Therefore, some of the small electrodes must be used to avoid excessive loss of welding metal and slag. Gas expansion. Gases are produced by the burning of the volatilization of electrode coating with the expanding with the heating of the boiling of the electrode tip. Coating the extended beyond with the metal with the tip of the electrode. Control the direction of the rapid gas expansion. Directs the molten metal global into the welded metal performed in the base metal. The electromagnetic force of the electrode tip is the electrode conductor with the molten metal the global at the type. Therefore, the global is affected with the magnetic force at 90 degrees at the direction of the current flow. The force is producing the pinching and effect of the metal globals produced with the separation of the molten metal that form the end of the electrode. There is a particular helpful to transforming the metal with the horizontal, vertical, overhead position welding. Electrical force, the force produced by the voltage across the poles and a small punch off the metal, regardless of the position of the weld. The force is especially helpful when one uses direct current, straight polarity, mineral coated electrodes which do not produce large volumes of the gas. 5. Surface tension. The force keeps the filler metal with the slag of the globules in contact with the molten metal welded material of the crater is known as the surface transfer tension. This helps to retain the molten metal with the horizontal, vertical, and overhead welding to determine the shape of the welding contours. The equipment needed for the shielding metal arc welding is much less complex than needed for the other than arc welding process. Manual welding equipment includes the power source, the transformer, DC generator, AC generator, DC rectifier, electrode holder, cables and connectors, clipping hammer, and wire brushing electrodes. Welding parameter, welding voltage current with the travel speed are very important to the quality of the deposit of the shield metal arc welding bead. Table 3.1 shows the voltage limits as known as the shield metal arc welding electrodes. The current limits are also shown in the appendix of the American Welding Society A5.1. Figure 3.3 through 3.9 shows the travel speeds for the electrodes listed in Table 3.1. Are reprinted in Military Handbook 56 Materials and Metal Processing Series of the Arc Welding, Department of Defense, 1968, non-copyrighted. Figure 310 for the three types of free flight metal transfer and welding arc. You have projected spray, repelled, and gravitational. All right, this shows the reprinted Military Handbook 56 Materials Military Processing Series Arc Welding, Department of Defense, 1968. Alright, you have your gas supply running to the shield gas with a DC welder with a contactor running also to the shield gas gun. The controls for governing the wire drive of the current gas flow with the current welder and cooling water if used, and with a wheel drive and wire reel running to the shield gas. Table 3.1. Establish voltage limits. Electrode 6010, 28 to 32 volt limits. 6011, 28 32. Electrode E60 13, 22 to 76. Electrode 70 to 18, 25 to 28. Electrode 70 24 to 26 to 32. Electrode 80 18, 22 to 28. Electrode 110 18, 25 to 30. Alright, gas metal arc welding, GMA. Gas metal arc welding process in which the electric arc is established between the solid consumable spool-fed electrode with the work with a piece with the arc of the electrode tip of the molten weld are shielded with the atmosphere by a gas. The welding process has been commonly called the metal generic gas or MIG welding. Therefore, two main types of metal transfer: the free flight or the short circuiting. With the free flight transfer can be projected spray, propelled, the gravitational globe, or globular. The three types of form of the free flight transfer are basically with the flat position welding in Figure 310, the modification of the free flight transfer to pulse current, which can be used in all welding portions with the short stick of the short circuiting transfer, sometimes called short arc, or so used with the low current with the welding with the materials in all position. The gas metal arc welding process is basically the same equipment as shown in Figure 311 in the American Welding Society D11. Describe the electrode shield gas and welding procedure for the gas metal arc welding using single electrodes. Alright, one advantage of the more advantage of the free flight of the transfer of the welding. High quality welds can be produced much faster with the small shielded metal arc welder than gas tungsten arc welding. Since flux is used, there is no chance for the entrapment of the slag in the welded material. The gas shield protects the arc so that that there are very little loose or alloy elements that metal transfers across the arc. Only minor welded splatter is produced. This is easily removed. The free flight process, the versatility can be successfully used with a wide variety of the metals and alloys: aluminum, copper, magnesium, nickel, many of the other alloys, as well as iron in most of the alloys of its alloys. The process can be operated with several ways, including semi or fully automatic. Gas metal arc welding is widely used in many of the industries and welding and provided with a variety of the materials and parts of the structure. Disadvantage: the major disadvantage of the free flight transfer is it cannot be used vertically overheated with the welding due to the high heat temperature, including the fluidity of the welding puddle. In addition, equipment is complex compared with the shield metal arc welding. Processing principles in the free flight transfer of liquid drop from the tip of the consumable electrode is detached with the travel free across the space between the electrode workpiece and before the plugging into the welded pool. Figure 310. When the transfer gravitational drop is detached with the gravity alone, the fall slowly through the arcing column. The projected type of the transfer, other forces of the drops in the initial acceleration project independently gravity toward the welded pool. During the repelled transfer forces the active liquid drop to give it the initial velocity directly away from the welded pool. The gravitational project modes of the free flight metal transfer may occur with the gas metal arc welding of steel, nickel alloys, and aluminum alloys using direct current electrode positive or reverse polarity arc, and properly selected type of the shield metal gas. The low current of the wire of these alloys must be met slowly. Large cylindrical drop from the tip of the detached with the force due to the gravity exceeds the surface of tension as in current increase with the electromagnetic force because of the significant total separation force increases with the rate of which the drops in form of the detached is lost with the increase with the current with the change of the curve with the change character of the arc and metal transfer. There are columns previously bell-shaped, the cylindrical and having related to the low brightness because of the narrow, more conical, as in bright center core of the droplets from the form of the wire type that become elongated during the magnetic pressure are detached at the much higher rate when carbon dioxide is used as a shield gas type of metal transfers in much different low, medium, reverse polarity currents of the drop area of the propelled from the work electrode eventually detached while moving away from the workpiece welded pool. This causes the extensive amount of the splatter. High currents of the transfers is less irregular because of the other than forces primarily electrical and overcoming the repelling force of direct current with reverse polarity recommended for the gas metal arc welding process. Straight polarity altering current can be used, both requiring precautions such as special coating on the electrode wire and special shield gas mixtures. Equipment needed for the solid wire free flight transfer of the welding includes the power supply, the welding gun, and mechanism for the feeding of the electrode filler wire. A set of controls. The two types of the power sources are used in free flight transfer of welding: constant current with a constant voltage motor generated with a DC rectifier power source. Either type may be used both. Figure 312 is a voltage current for the E70S 21 16-inch diameter electrode shield gas argon 2% oxygen addition. Your current amperes from 0 to 500. You have a global transfer region and a splay transfer region between the voltage ranges of 15 and 35. Your reprinted of circular TRM 302 welding characters construction steel AR 36A 15A 156. Voltage current voltage versus the E70's S21 16-inch diameter electro carbon dioxide shield. Your amperes run from 0 to 500. Your range is in between 100 and 500. 400. We have the repel transfer region, short circuit transfer region, project transfer region voltage in volts.